equal to 1, choose the expression that completes the identity. Actually, well, everybody look, remember we already know from unit circle, we already know that from unit circle that if I select just one triangle, right triangle here, and I know that this is X, this is Y, and every point on the unit circle is cosine sine. So this point is X cosine and Y, and this is 1. By unit circle, we have already proved that sine squared X plus cosine squared X is equal to 1. We already know that identity. Okay, so we already divided. So let me divide cosine squared X. Cosine squared X divided by cosine squared X. We did it the other day, but some people were not seeing the board. And notice that this quantity here is tangent. So now I have tangent squared X. Cosine squared divided by cosine squared is 1. And 1 over cosine squared X is secant. So this is secant squared X. So this is not even, so everybody should be able to do this. If you remember the Pythagorean identities, if you're told to show the work, you just show what I said now. And then the left-hand side, whenever you're proving an identity, you start from the one that is more complicated, and actually try to change tangent and cotangent to sine and cosine. It is better to do that. There are some of them I'm going to let you do, but just what I said, even an odd function. Tangent is an odd function, therefore cos tangent of negative angle is it going to be negative at that angle. Since cotangent is an odd function, since tangent is an odd function, cotangent is an odd function also. Therefore, cot of a negative angle is negative cot angle, whatever the angle is. That's because it's an odd function. Only cosine and secant are even functions. You have your identities with you, so you can actually use it sometimes. So this is sum and difference. So let's go ahead and expand this. Remember, we started it the other day. Whenever cosine is positive, this is alpha though, alpha here. All right, my alpha refused to write as an alpha. I'm going to try again, alpha. And write it A for now. So if I'm expanding this sum of cosine, it is the same as cosine alpha cosine beta minus sine alpha sine beta. All right, because it's in the formula sheet, you don't really have to memorize it, but there are things you need to know about. So that there is going to be a change of sign whenever it is cosine, period. So that's all. There's no question in that. So there is no question in that. Let's go to, but suppose, by the way, what if I have cosine A minus cosine B minus B? Then, because there's sign here, I'm going to change sign. So cos A cos B plus sine A sine B. So I said, what if there is a negative here? Then the sign will always change for cosine. All right. Okay, let's go to sine. Sine A sine B, the sign follows the same way. The sine is going to follow the same way. Okay, so sine A plus sine B is equal to sine A sine A cos B plus, there is no sign change, plus sine B cos A. Okay, and that's all you're told to show. It's not going to be a lot of those questions because they are actually formula, they're in formula sheet. So there is nothing if you did that. But once you apply it, application, use the sum and difference formula to apply. Now, this time I am told to use sum and difference formula to simplify this. So I can do it any way I can. So in how many ways or what and what do I add? Okay, so I can say, and when I add it, remember your answer has to be exact. So we got to be careful. So I want to find multiples of exact forms or special right triangles that will give me 11 pi over 12. Okay, so we can start by, I know that 9 over 12 plus 2 over 12. This is trying to find a way to do it. You don't have to use what I'm using. But the important thing is your numerator adding up to 11? Yes. My numerator is adding up to 11. So 9 pi over 12 plus 2 pi over 12. So, okay, because I found two numbers that can, by the way, you can use subtraction and get something. So this time I want to rewrite it as 9 pi over 12 can be written as 3 over 4, but by the way, 3 pi over 4, 3 pi over 4. Okay, so let me now write it the way that, so I will say sine 3 pi over 4 plus 2 pi over 12 is the same as pi over 6. All right, so now I want to first of all rewrite it in sum and difference formula. So rewrite it in sum and difference formula. Don't forget that this is sine. Okay, so I want to rewrite sine. I know it is sine. Suppose this is my A. It's always good to, suppose this is my A and this is my B. So, and I have sine A and B, sine A plus B for now, equal to sine A cos B, and it is sine, the sign, the plus sign does not change, plus sine B cos A. All right, and I already know that my sine, my A is 3 pi over 4. And by the way, what is 3 pi over 4? What is 3 pi over 4? It is not up to 180. So it's in the second quadrant. So let's find out. And by the way, pi over 4 is 45 degrees. So it is 3 times 45 degrees. 45 plus 45 is 90. 90 plus 45 is 135. So we're talking about an angle in the second quadrant, 135 degrees. All right. So all these things are not asking me for one thing. For, do I know the angle in a standard position? Can I find the reference angle? Do I know the signs? Okay. So if it is 135 degrees here, then the angle in question, the reference angle in question is 45 degrees. All right. All right, sine is positive in the second quadrant, cosine is negative, so I can't forget that. So make sure that wherever cosine is, put negative there. Wherever cosine is, put negative there. So sine of A, which is 45 degrees, is root 2 over 2. All right. And then pi over 6 is 30. So I see cosine of B, and what is cos 30? We already found it before, but let's find it again quickly. We're going to find cos 30 immediately. Cos 30 is adjacent over hypotenuse. So root 3 negative root 3 over 2 plus sine B. And what is my B? B is pi over 6. Sine B is 1/2, sine 30. Sine 30 is 1/2. And what is cosine of 45 degrees? Root 2 over 3. Root 2 over 3 in the second quadrant for cosine is negative. Root 2 over 2, I mean. So cosine of 45 degrees is root 2 over 2. Okay, so let's simplify. I want to put this in parentheses that way. So we can simplify, and I have root 2 minus root 3 all over 2 plus 1 minus root 2 all over 2. I'm told to leave my answer in exact form, and I can stop there or open the parentheses and simplify more. If I open the parentheses and simplify more, root 2 and root 2 will go from here. Say something. Hello?
Yes, ma'am, I'm good.
Yes, good. Are you okay now?
Yes, ma'am.
Okay, so now I am opening this parenthesis because I see that something can cancel. If I open that parenthesis, I see that this root 2 and negative root 2 can cancel, and the denominator is the same. So I can rewrite my answer as 1 minus root 3. So this is the final, final answer. So remember, somebody asked you a question, gave you an angle in a pi, and they want to know if you know all the unit circle. That's all it is. Somebody wants to take you around the unit circle. See if you know that all students take calculus. See if you know that angle in the second quadrant is only sine positive, cosine is negative. See if you know your reference angle and all the rest of them. So many ways you can do it. And by the way, let's see if we can get another one. Let's go to another one and see. So let's do another one like this. It's not, by the way, it's not that bad. So all you need to know is the special right triangles, your unit circle, the reference angle, all students take calculus, and so on, everything. You need to know just everything. Okay, so the one we did is number 15. Let's do one more. One more of sum and difference formula. Okay, so the angle is, if you look at the angle, it's already an angle in the third quadrant, because you see that angle is in the third quadrant. But we're not interested in changing it to degree. What we are interested in, finding any two angles that will sum up to that angle. And by the way, even if I don't know what it is, no problem, I can multiply it. I can just go ahead and multiply 13 pi over 12 multiplied by the multiplier. Multiplier changing to degree. And then 6 go here, I got 2, 6 go here. Remember, I don't have to do this step, but if you're confused, go ahead and do it. Sometimes if you guess wrong, so you might want to do it. Okay, so 13 times 3, I have 39 over 2. So that angle is 39 over 2. And let's see, I want to make sure that I did so 6 go here, 2, 6 go here. So this is supposed to be 30 though. Okay, so all right. So, and then if I divide 30 by 2, I have 15. All right, so then let me get my calculator and multiply that out. I want to see what exactly that angle is. So, so I'm going to turn my calculator on, find the exact angle in degree. It's not going to hurt me to find it. That way I'll know what to do. So 13 multiply 15, and I have the angle is 195. Okay, so now I know the angle 195. The angle in degrees is 195. So how can I add or subtract two angles, two special angles, not just two angles, two special angles to give me 195? Okay. What about if I do 180? 180 and 15 is not going to be good. What about if I do 150? So 150 plus 45 is 195. I hope you agree. It's 150 degrees plus 45 degrees. No, whatever you can do to make sure you get it right, do it. I did now. Instead of making 12 this, then I get the answer right. I change it to degree. When I finish solving the problem, I change it back to radian. So now I found out that the angle in question, 13 pi over 12, is 195. Now the next thing to do, that number is 15. Let me go back. All right, so 150 plus 45 is 195. So since it's 195 degrees, I found out 150 plus 45 is 180. Another thing I need to know now is that 150 is angle in the second quadrant. Sine will be positive, cosine will be negative. And by the way, I'm using, let me see if I'm told to use sine or cosine. Okay, so I use the appropriate sum of cosine. Okay, so they didn't tell you anything. They just told you to use the appropriate sine or sum of difference. Okay, so I already know that sine A plus B plus B is equal to sine A cos B minus, plus sine B cos A. Then I'm going to draw a line there. Okay, and then I want to A angle 50 degrees is 150 is my A, and my B is 45 degrees. All right, so I can go ahead and write them in here. And by the way, you know that 150 degrees, you can use that to, you can convert it back to radian. That's what I'm trying to say. So you can convert back to radian. 150 multiply, if you're told to show work. If you're not told to show work, don't waste your time. So, pi over 180. Okay. And then you finish up having 5 pi over 6. So you can say 5 pi over 6. Okay, so sine 5 pi over 6 cosine of 45 is root 2 over 2. Root 2 over 2. I can just say pi over 4 there. That way, I'm just going to start pi over 4. That way, let me say pi over 4 plus sine B, sine pi over 4 cosine of 5 pi over 6. We already know now that pi pi over 6 is 150 degrees. And if you like, you can draw, come on. And then if you like, you draw the away for me. All right. Okay, let's go back. Okay, so if you like, you draw a unit circle and make yourself a small reference angle here. And that 180 reference angle in the second quadrant is 180 minus theta. Theta is 150. 180 minus 150 is 30. So remember that the reference here is 30 degrees. So that's 30 degrees. Sine of 30 is 1/2. So let's go ahead and put 1/2 here without a negative, because sine is positive in the second quadrant. And then 45 degrees. 45 degrees is positive, is first quadrant. Cosine of 45 degrees is √2/2 plus sine pi/4, which is 45 degrees, is √2/2 also. Cosine of 5 pi/6 is cosine of 150. Cosine is negative in the second quadrant, so negative, what is cosine of 30? And cosine of 30 is √3/2. √3/2. Okay, it's time to simplify. Time to simplify. Okay, so I just want us to know where is our boundary. I'm gonna draw some kind of line and get my boundary. All right, now I also want to use parentheses for multiplication. Okay, so right here on the left-hand side, right here, I have √2/. If I'm multiplying √2/4, and then plus, I have, if I put plus here, I'm going to put negative also. √2 times √3 is √6, all over 4 also. And then I can rewrite my answer as √2 minus √6/4. And I believe this is my final answer. I can't simplify it anymore. I can't simplify this anymore because guess what? Okay, one more of sum and difference. And by the way, sum and difference is the beginning. That is the root, the mother of all the other, all these other trig ratios. The mother. Okay, so one last one, cosine, and then we go to something else. So let's do, I think that last one will be good for number 17 is going to be good. And that number 17 is cosine 7 pi/12. So first of all, I am not in a hurry to start, but I know that 3 pi/12 plus 4 pi/12 will give me 7 pi/12. So let me do that. So cosine of 3 pi/12 plus 4 pi/12. Remember, if you don't remember, no problem, convert it to degree like we did before. Then later on change to radian. So we know that 3 pi/4, this implies cosine of pi/4 plus 3 pi, not is no pi/3. Let me, pi/3. 4 pi/4 is pi/3. All right, so this is pi/3. Pi/4 is 45 degrees. Pi/3 is 60 degrees. Cosine is, this is sum and difference. Cosine is addition. So I can't forget to change the sign. That's part of the test in this question. So now I want to do sum and difference for addition, sine A and B, A plus B. So I will write cosine, this implies, I'm going to continue this here. cosine cos pi over 4 cos pi over 3 minus, don't forget, sine pi over 4 sine pi over 3. All right. Cosine pi over 4 is 40, cosine of 45 degrees. So it is the same as root 2 over 2. Cosine pi over 3 is 60 degrees. Cosine of 60 degrees is 1/2. Sine pi over 4 is 45 degrees, root 2 over 2. Sine pi over 3 is 60 degrees. Cosine of 60 degrees is root 3 over 2. Okay. All right, now time to isolate, simplify. I'm going to multiply here. I have root 2 over 4 minus root 6 over 4. If you don't agree, let me know. You don't have to agree, by the way, because people make mistakes. So if I make a mistake and you keep quiet, you're really not helping yourself, not helping me either. So now I can simplify. I have root 2 minus root 6 all over 4 is my final answer. That's what I can do in exact form. One thing you need to know, I think as a student last year decided to ignore all the exact form and use her calculator and change all to decimal. But anyway, I can tell you that if you don't answer the question like the way you're told to answer it in exact form, you are not going to get a good grade. You won't like your grade. You are not going to like your grade. Your answer has to be careful to know. You want to make sure you know how to type in square root sign in MATLAB Math.